Another video, this time the big DC motor driver. Notice we have some codes, so we might as well go check out that code. This is from the Portenta Pro Community Solutions, so you could just go to examples, find it, find the actual one. It's .227. But let's just first of all check that it actually compiles. And then we'll look into the wires. While it's compiling, let's go look at the information we have. Don't forget at the bottom of the page, we have the xiao image, and then back at here, we have this image. So let's open that image in its own. So we're talking about this thing, and it's kind of the other way around from what we've got at the moment. Let me just pause. Okay, that looks more like the diagram. So these top two, which I've got them both green, are just going to go to the motor. And the reason I don't have those different colors is if the motor's going the wrong direction, I can just flip them. It's a DC motor. You can just flip the two wires to it. The next one there is ground, should be black, and the last one, bin. And that's going to go to my external batteries because the large DC motor, you can't run multiple amps and a higher voltage. I think this one only goes up to 36 volts through a microcontroller. So you have to use a motor driver of some sort or some fancy transistors. It's kind of the same thing. For this motor driver to work, it must have a minimum of 6 volts. That's why we got the double battery pack there. And I'm just using, a silly little motor. We have this once again is for the Portenta, but D3, D4, D5 should not be hard. 3B3 and ground should not be hard. Notice there are some LEDs that are going to be right about there, if it works. And some students have a hard time with this. I'm going to, okay, first of all, we had an error. LEDB didn't work because it should be built in. The Portenta has multiple colored lights, but the xiao doesn't. Worthwhile knowing. Okay, let's fire that up. Let's see this code. D3, D4, D5, all for output. Notice this one is PWM output, 0 to 255, whereas these two are digital. Interesting. I don't know if I have to list that as A4. Once again, working always trumps talking. So it's turning off it's actually turning on the light. And it looks like it compiled, so that's awesome. For the big motor driver, you've got two things to set for direction, D5 and D3. D4 is going to be the speed of the motor. So here we're doing D4 at 50, so it's medium speed. D4 at 0, which is off. Then we're changing the direction. D4 at 50 and D4 at 255. So this is fast. And about a second or 3 seconds between them. Not massively complex code. And then a big, long 9-second wait. Okay. Why are there two directions when we could do left was 0 and right was 1? Because if you put these both fully on, some motors can break. And if you put these both fully off, some motors can be set to glide. I don't think this motor would work that way. It doesn't have a brake as far as I know. So I'll hook up the wires. That's what it should be, and get back to you. Okay, what do we have? We have ground, 3v3, 3v3. So we skip 2 Then we've got ground 3v3, right away D5, which is right there. Then skip to D4, which is right there. Skip 1 and D3. Ground red, and then we have the lines to the batteries and the motor, which is right here. So we've already got the code on. Let's plug it in. Let's have a look at the code first again. It's gonna go 50 of 255 for 3 seconds and then stop for 3 seconds, change directions 50 and 255. So at the end, it should go quite fast. We're not going to probably be able to see it move too much. Here it is. Okay. So it stopped for 3 seconds, starts the other direction, then goes super fast, then done for 9 seconds. Notice the LED did go on. The red is the power. Can you see that? And then the orange went on when it starts. It is actually going a different direction that time. Once again, hard to see. But all good. We can finish this.